Hello, everybody. Good afternoon. So, are you all here already? Okay. Can you all hear me or not? Can you all hear me? If you can hear me, can you type in the comments here? Because to be honest, I'm not sure if you all are with me or not. Um, so, hello, good evening, everybody. I'm Chu Sensei. Welcome back. Uh, welcome to my live in here. So hopefully you all are ready for today. Okay, so if you can you all hear me or not? If you can hear me, can you at least give me a response so that I know that you all can hear me. Okay. Okay. So I guess should be okay. Huh? All right. So hello. Good evening. Welcome to this one. Huh? Okay. So without further ado, shall we begin our slot for talk for today? Okay. So let's begin. Okay. So today we are. The answer has already been attached to the this what the answer has been attached to the uh, how to put in words has been put into the YouTube link there. Can you see the YouTube link? You click on the description there. The answer scheme is down there. Okay. Okay. So if you see the answer scheme there, then that is the answer scheme for today lah. So I'm just going so that you don't have to focus on. You can focus on listening. Okay. And then while I go through each of the questions one by one. All right. So without further ado, shall we begin? Okay. So hello to those who just know me. I'm Mr. Chu. I'm 44 years old this year, 2025 already. Originally in Pontian. So currently teaching in SMK Tasik Utara. I've been teaching since 2003 until 2025. So this is my 22nd years of teaching. So hopefully for more lah. Okay. So here are a few of my experiences and involvements. So I was ex-national trainer for STPM Chemistry in PBS. I present for STPM Chemistry in various places all over Malaysia. I also wrote a few books in here. I believe that this one, but I'm so sorry, SEM 1 and SEM 3 is no longer available because I finished you know that we are going to change our syllabus soon, so I don't see the points of printing anymore lah. So I'm so sorry for that. Okay. But never mind. And thank you very much for your support all this while. I really appreciate so much. Okay. And then okay, so now let's straight away go to the scheme of assessment. So for the scheme of assessment, no matter term 1, term 2, or term 3, they all have the same scheme of assessment. So our chemistry paper is made of 3 sections: section A, section B, section C, where you have 15 compulsory to answer question. You have section B, 2 compulsory answer structure. And finally, section C, you have 2 compulsory to answer this one. Okay, now here is a little technique that I would like to share with you. 1.5 hours is 90 minutes, isn't it? So if 90 minutes, can you imagine? This one is 15 marks. This one also 15 marks. This one is 2 essay, 15 marks. So 1 essay is 15 marks each, right? So in here, you have 4 equal sections, each of them sharing equals a portion of time. So you should distribute your mark equally. Okay. So I will recommend here you put 20 minutes for objective. here you also put 20 minutes for structure. Now essay, because you require more writing, so I would recommend you to put at least 25 minutes and 25 minutes, so that you see your timing is just nice. So what am I trying to highlight to you in here is, don't over focus only on one section. You should distribute all the section equally. For essay, you spend a little bit more time, because one essay is 15 marks in here. So altogether 60 marks, which is then contributing 26.67% for each semester. So 3 semester is 80%. Okay, so that is the technique of more or less of how you should assess your this one. Okay, all right. So are you ready for this one? Okay, so a little bit more tips in here is that here are the past year question analysis that I did for you. A very general past year question analysis, but I hope that you more or less provide you an insight of what are the questions asked in last year. Okay, so now I understand that some of you cannot will ask me, teacher, what chapter will come out this year? I can only say that I'm not sure, because out of 6 there is only 5. That means one chapter is not asked, and I'm not that good enough to predict which one will not come out. But if I were to focus, I will definitely focus on chapter 1. If I were to focus, I'll definitely focus on chapter 1 this year. And this is based on, okay, so this is based on my own experiences. Chapter 1, chapter 2, chapter 3, chapter 4, and chapter 6. 6, I will recommend you to focus a little bit on phase equilibria, because but it doesn't mean that other is not important. I never said that. Okay, and chapter 5, you can of course focus, but it is the least prioritized. Okay, but like I said, this is just based on my own this one prediction. May not be accurate. So later didn't come out, you don't come and blame me to say, Mr. Chu said that will come out. So that's why I said I don't want to predict. Okay. So well, this is the analysis. So if you want later, I will share in various groups later. Actually, I share a few with a few teachers already. Okay. All right. So shall we begin? Okay. So a little bit of advice before examination for the remaining 2 days. Make sure that you have your own. Make all details. If possible, make your own short notes based on your understanding, and check with your teacher reference for online sources. I understand that some of my students also use ChatGPT to do this one, but ChatGPT, if they have a reference sources, you better read from the reference sources. Sometimes ChatGPT takes for a little bit part from here and there. Okay, so but don't what I try to say is, don't trust ChatGPT too much. Okay. Okay. And then you must do all past year questions in the remaining 2 days left. I will recommend you all to, if you haven't finished all the past year question, you definitely can do. And there are various sources nowadays to access to all the past year questions. I believe that your teachers also already share with you, because so far for every semester after you do your examination, I will definitely share a post answer scheme, but I know my answer scheme is not like 100% no. Okay, but at least it give you how to put in words, at least a guideline for you to know at least how to answer to the questions. And every semester I will do that. If you already follow me for quite some time, you should know that you can easily find my suggested answer everywhere. And last but not least, now it's still semester 1. You have semester 2 and 3 to go. I will usually recommend you all to do a study group and together do some exercises, practices. So now you already know the technique already. So I hope that in the future, coming semester 2 and 3, you'll be able to do that. Okay. All right. So that is for a little bit of tips before this one. Okay. All right. So can we go to our main topic today? So our main talks for today is I've prepared for you a set of the questions that I personally feel that are the sets of the questions that might come out. So I just randomly choose some exercises and then try my best to teach you on how to answer all the questions. All right. So hopefully you all will stay until the end of the session today. Okay. All right. So let's begin. Okay. So okay. So during examination, what I recommend you all to do is uh, wait. Sorry, sorry, accidentally keep closed. Okay, okay. So, okay, so in here, sorry, can you give me one moment? Okay, so you have section A, which is time consumed, 15 to 20 minutes. Usually questions to be answered 15. So average time allocated for each question is 1 minute 20 seconds. In other words, so go through the question as fast as you can and answer those who are confident in, especially when involved theoretical part. But when it comes to certain calculations, which can get very complicated every year, if you notice carefully, calculation question can get 3 to 4 questions only lah. So if you don't know how to calculate, don't advise you to spend too much time on the calculation part, because this is the time part where it will drag you down. Furthermore, it's just 1 marks only, so I don't want you to focus too much only for one questions. Okay, so you have to spend your time wisely lah. That's what I try to say in here, right? Okay, so shall we go to the main objective? So let's go to the section A of our talks today. So I know that okay, let's together try to finish the questions. Okay, helium is the second element of the periodic table. Tritium is the isotope of the hydrogen. What is the same in atoms of the helium and atom of hydrogen 3? So, teacher, what about the proton number? So the proton number you can always check from the periodic tables. So you can check from the periodic table. The proton number of the hydrogen is 1, helium is 2. So in here I already did the tables for you where you have the proton, electron, and also neutron. Now, because this is a neutrally charged subparticles, so in terms of the proton and electron, that should be the same. So neutron in here is 2, where neutron in here is 3 minus 1, you get 2 lah. 4 minus 2, you get 2 also, right? So in here, what are the same? As you can see from the tables in here, the one that is the same is the number of the neutrons in here, okay? Okay, so number 1 is B, very straightforward, isn't it? Okay. Okay, then number 2, in which species are the number of proton, neutron, and electrons are all different? Okay, we are looking for all difference. Okay, so in here you have boron 11, you have 6 proton, 5 proton, 5 proton, sorry, 5 proton. Typing error. Mr. Chu, sometimes like that one, I might accidentally type error in here. Okay, so please forgive me if I accidentally type error. I will try my best to correct it. Okay, okay. So 5 proton, 6 neutron, and electron is this one. 5 also. So you shall have A. As for B, proton is 9. Neutron is 10, electron is also 10, so they have the same neutron and electron. As for the sodium, you have a 23, 11 Na plus. Na plus means that you donate 1 electron. So you have 11 proton, 12 neutron, and 10 electron. And then finally 24, 12, and 10. So you have this one, 12, 12, and 10, if you calculate properly. So teacher, is there a way that we can straight away know that the answer? I don't dare to say that there is a very straightforward way for you to quickly know the answer, but at least you can quickly know that you should eliminate A first. Why I say that you can quickly eliminate A? Because if it is a neutral charge, if it is a no charge species, then proton and electron should be the same. So A is not the answer already. So sometimes you have to be smart lah. Okay, so based on here, the answer in here is C, as you can see, right? Okay, so that is how you are going to answer for question number 2, right? Okay, so shall we move on to question 3? Any questions so far? If you can always type in, please type in the comments section there if you have any questions, so that I can show everyone the questions, so that, and then I can answer through the live here, right? Okay, can? Okay, let's continue. Okay, number 3. The most common ion molecules reaction in the gas cloud of the universe is shown at below. You have H2 gas plus H2 plus gas give H gas plus H3 plus gas. What could be the composition of the H3 plus in here? Okay. So from the particles of the H3 plus, you have proton is 3, neutron is 0, and then electron is 2. Okay, so 1 minus 1 neutron is 0 lah. Okay, so from here the answer in here is donkey D. Okay, okay, so that is for question 1 to 3. All of them are focusing on the subparticles here. I'm so sorry. I mislooked that options. I should have asked more variables questions. Okay. Never mind. Then let's go to number 4. In which option does all these 3 particles has the same electronic configuration and the same number of the neutron? Now, how do we know that they have the same electronic configuration? Teacher, do we really have to write electronic configuration one by one? No need. So in here, what makes a species have the same electronic configurations? That means they have the same number of electron, and we have a special terms for it. If you have same number of electrons, we call them as isoelectronic. So that is the terms that we use if you want to express it as the same number of electrons here. Okay, so they're given to you, each of them their nucleon number. Okay, so let's together calculate one by one. So for proton, nitrogen 3 minus, oxygen 2 minus, F minus, you have neutron is 15 minus 7. 15 minus 7, you got 8. 16 minus 7, you got 8. 19 minus 9, you get 10. Okay, and then for the electrons, because the proton in here is the, I write lah, in case some of you cannot don't understand. So this is 7, this is 8, and this is 9 in here. So you can get this one. Okay, as for the next one, neutron is 10, electron 10. All of them are 10 in here. Okay, so you can see that same number of electron and same number of this one. Okay, so that is how for B. And then for C, you have 9, proton number 9, 10, and 11 respectively. Okay, so you shall have the neutron is 10, 10, 12 accordingly. Electron is 10, 10, 10. Okay, because 11, because plus means that minus 1 electron that you have 10. And then finally for the donkey D, you have the neon is 10, 11, 12. Okay. Okay, so you can see from the numerical value in here, you have 12, 12, 12, and then electron is 10, 11, 10. Okay, so the best answer in here is boy B. Okay, okay, so I'm so sorry lah, because my questions, a lot of them has all these particles calculations. So I just want you to familiarize with it lah. Okay. Okay, so hopefully you all will be able to answer accordingly lah. Okay, so of course this is not a very good set of questions, especially for the objective. So I still hope that you'll be able to help you to understand better lah. Right? Okay, so shall we move on to the next one? Okay, so the next one is, which of the following molecules have the tetrahedral shape? Okay, so in order to draw this, I'm not going to show you the 4-step methods. You can use the 4-step methods to draw all these. Yes. Then you have to, you have to draw the Lewis structure in order to find out what shape is it, isn't it? Okay, so I'm going to straight away shows you the shape. So the NH4, this is how NH4 looks like. Okay, so for KrF4, So this is how KrF4 looks like. 2 bond pair, 4 lone pair. This ammonia is 4 bond pair, and then SF4 you have 1 lone pair, 4 bond pair, and then finally SO4 2 minus is this one. Teacher, in the real structure and essay, do we really have to draw like how you draw on the screen right now for ammonia ion and also ammonium ion and also sulfate ion? Yes, you have to draw like exactly how I draw inside here, and then inside the ammonia contain one dative bond. If possible, try your best to show the dative bond here. So you have to show the dative bonds in the ammonia in here. They quite stress on this nowadays. So you might wanted to highlight on the dative bond inside the ammonia in here. Okay, so and then based on this, so what are the shape for each of them respectively? So NH4 is tetrahedral, KrF4 is square planar, SF4 is seesaw, and then the SO4 2 minus is also tetrahedral. Okay, so as a result, what is your answer in here? So your answer for this 5 is 1 and 4. Okay, 1 and 4 correct. Okay. All right. Any questions so far? All right. So hopefully no questions. Sorry, I go and get water. Okay. So wait. Okay. So teacher, may I know if there's a technique to remember molecular shape or molecular ion? I'm so sorry, the own technique is keep on revising. I cannot, this one. You have to memorize a little bit on here. Okay, next one. Teacher, how do we know what are the shape of molecule when we meet unfamiliar molecule during exam? Now you can use the 4-step methods. The 4-step methods are the one that the 4-step methods are the methods that I share with you. Later, after this lesson, you can go to my YouTube channels and you look for chemical bonding. Inside there, I teach you one step by step of how you can draw this one. The most important thing is you have to, there are 4 steps I just generally explain to you in here. First is calculate total number of valence electron. And then from the total number of valence electron, you put a bond, okay? And then after that, you put the surrounding to become octet. And then if there is lone pair electrons, remaining electron you put at the center lah. And if the center atom is not the octet, you can put in here. Okay. Teacher, we have to consider formal charge when you draw the Lewis structure. Yes, you have to. You have to consider the formal charge. Okay. Okay. Thank you. Thank you very much, Kazi, for helping me to answer some of the questions in there. Okay. The answer is already inside the description there. Okay. Okay, so shall we continue? Okay, number 6. Which of the following cases could explain from the view of the formation of dative bond only? Okay, so number 1, when ammonia is reacted with hydrochloric acid, a white film of ammonium chloride is formed. Okay, so in here you can see from the structure in here, it is how the ammonia react with the HCl to form the NH4Cl. This is the correct structure of the NH4Cl that I draw in here. Should formal charge be shown? Yes, formal charge should be shown. In the nowadays Lewis structure, formal charge has become more and more important already. Okay, though in our current syllabus we do not stress that much, but in the 4 basic molecular ion such as sulfate, nitrate, carbonate, and also cyanide, you should be able to express the formal charge for each of them. All right. Okay. So how do you calculate formal charge, sir? Now there is a formula of how to calculate formal charge. You have to find on other YouTubes because in the current syllabus, we don't have the YouTube for that, but you can find from others. Okay. Later, if possible, I don't know how to share in the screen in here. Okay. Okay. So sorry. Okay. And then So shall we continue number 2? Okay, so CuH2O62 plus is blue while CuCl4 2- is green. So this is the structure of the CuH2O62 plus and CuCl4 2-. Okay, so this is the complexes. Okay, and then number 3, and you also form dative bond. Do you see that? Number 3, aluminum chloride form dimers of Al2Cl6 under room condition. So this is the dimer of the Al2Cl6, also uses dative bond in here. Whereas CO2 is a gas while SiO2 is a solid under room temperature. So for information, this is how the structure of the CO2 and SiO2 looks like. So inside the SiO4, I just draw the giant. Always remember, when you describe the CO2, I will usually recommend you all to write CO2 is a simple covalent molecule. Okay. I use mouse to write. So my handwriting will be a little bit weird. Okay. Okay. CO2 is a simple molecule, while SO2 is what we call as a giant covalent structure, and this is how SiO2 looks like. Okay. Of course, it has the same shape as this one. Okay. So that is why SiO2 is a solid while CO2 is a gas. Okay, so you can explain from the actual this one. Okay, so which of the following is correct? So 1 correct, 2 correct, 3 also correct. Okay, so because to form all this you need dative bond. Okay, to form all this you need dative bond. So 1, 2, 3 are all correct here. Okay. Okay, so can we move to the side here? Okay, never mind. Okay, so that is for number 6. Okay. Okay, so shall we continue to number 7? Okay, so number 7, the molecular. Wait, I come back to this one. One of you asked me, teacher, is cubic close pack or hexagonal close pack for diamond? As answer from the books are different. Diamond is cubic close pack. Diamond is hexagonal structure. Hexagonal close pack we call hexagonal close pack. Okay, HCP, hexagonal close pack. If you want, you Google by yourself what is hexagonal close pack in here means. Okay. Okay, so shall we go back? Okay, so the molecular structure of an amino acid alanine is given below. So which of the following are correct for the angle of ABCD? So in here, in the real Lewis structure, they don't show you lone pair electrons. You have to know by yourself that there is one lone pair electron at the ammonia, at the nitrogen in here. And then for oxygen, there are 2 lone pair electrons in here. Okay, so this is something that you must know by yourself for this one. Okay, so it has something to do, of course, actually, to be honest, it also has something to do with the formal charge in here. Later at the end of the question, if you still wanted to know how do we know all this, I will explain to you at the end of these sections if we have extra times. Okay, so but students, you should know that nitrogen, when you have 3 covalent bond, you have 1 lone pair electron. Oxygen, when you have 2 covalent bond, you should have 2 lone pair electrons. Okay. Okay. So in here, nitrogen in here is trigonal planar. Okay. So the angle is 107. B is tetrahedral, so 109 degree. C in here is trigonal planar 120, and then the D in here is a bend shape 104. Okay, so the correct angle for all of them here is donkey D. Okay, so that is how you are going to answer for question number 7 in here. Okay, okay, so any questions so far? Ken? Okay, so that is for number 7. Okay, immediately we move to number 8, shall we? Okay, phosphorus pentachloride decomposed according to the equation PCl5 gives PCl3 plus Cl2. So when 1.3 times 10 power of negative 2 of PCl5 is heated at 727 degrees Celsius in a decimeter cube flask, total pressure formed is 150 kilopascal. What is the partial pressure of a fluorine in the pascal in the flask in here? Now this is actually from a very old past year question, 2005 past year questions. Okay, so in here you know that PCl3 will dissociate to be PCl5 will dissociate to become PCl3 plus Cl2. In here, given to you, your initial mole in here is 1.3 times 10 power of negative 2. So this is the initial, okay? So initial, you have 1.3, so 1.3 times 10 power of negative 2, okay? So this is 0, this is 0, isn't it? So at equilibrium, okay? So at equilibrium, because stoichiometrically 1 to 1, isn't it? You have to find out what is the here minus alpha, okay? Because stoichiometrically 1 to 1 to 1, So here minus alpha, here plus alpha, here plus alpha. So you have at equilibrium, you have 1.3 times 10 power of negative 2 minus alpha, okay? And then here you have alpha and alpha, isn't it? So your keyword right now is how do you, from all this information, you have temperature, you have volume, now you have total pressure to calculate the total moles in here, okay? Okay, so can I go back to this one? Some of you ask, teachers, should we show dative bond in our Lewis structure? Yes, you have to. If there is a dative bond, you have to show your dative bond. Yes, okay. Okay, so can we continue to the solution? Okay. So you use PV equals to nRT. So when you use PV equals to nRT, make sure that your pressure is in Pascal. So if it is kilo, you have to times 10 power of 3. Volume must be in meter cube. So if you have decimeter cube, you have to times 10 power of negative 3. Okay. N is what you want to find. This is N total at this condition. Then 8.31, then 273 plus 727. So press your calculator, you get your total mole is 0.018 moles. Okay. And then you use PCl5, give PCl3 plus Cl2. So as I described in here, so you get your total mole is 0.018. Therefore, press your calculator, your X is equals to 0.05. So your partial pressure of XCl2 is partial 0.05 over the total mole, 0.018 times 150. So you get 42 kilopascal. Okay, so the answer in here is C. So this is the way of how you are going to calculate for such. If you don't know how to calculate or you feel that it's too bothersome to calculate such a long questions, maybe you will want to skip this objective question and try other objective question first. Okay, some of the calculation question can get quite complicated. Okay. Okay, so that is how you're going to solve for number 8. All right, any questions on number 8 so far? Right, so if no problem, then we go to the next one, shall we? Am I going too fast? If I'm going too fast, you can always slow me down at the comment. Okay, number 9. Liquid P and Q are of the same volume are allowed to evaporate. It is found out that P evaporate first before Q does. What does this statement explain? Okay, A. When you have two vessels, one of them evaporate faster. Okay, so let's say you have vessel P and vessel Q. Okay, so when we say that P evaporate faster, okay, so Q is still full like this. This is Q. So in other words, P is easily to vaporize. Okay, when P is easily to vaporize, what does it mean? Okay, so A, vapor pressure of P is lower than Q. Is it correct? No. When you vaporize first, your vapor pressure is actually higher. Okay, higher the vapor pressure, easier to evaporate. Okay. So the intermolecular forces is V. Now, when you are easily evaporated, what does it mean? You actually have a weaker intermolecular forces. So B is correct. So the density of Q is higher than P. Now, density has no relationship with the whether it's density, whether it's what easily vaporized or not. No, okay. So, and then Q is more viscous than P. Teacher, what is viscosity? Viscosity is the ability to flow, okay? So, when you have a strong intermolecular forces, usually you are less viscous, okay? Okay, so the best answer in here is boy B, okay? So that is for number 9, all right? Okay, so any questions? Actually, in the structure essay, I haven't really seen these vapor pressure questions before. So you might want to take notes on the vapor pressure if possible. Okay. Okay, so that is for number 9. Okay, then we goes to the next one, number 10. Okay, which of the following statement about rate constant? P is also more volatile. Yes, P is more volatile. More volatile doesn't mean that it's more viscous. No, volatility and viscosity are two different things. Okay. Okay. But volatility is not in the selection of this question. But if it is say more volatile, yes, P is more volatile. Very good. Okay, so which of the following statement about rate constant for a chemical reaction is true? A, unit is S minus 1. Now, is all the rate constant has the unit S minus 1? No, it depends on the order. Okay, so S minus 1 is for first order of reactions. Okay. B, does rate constant changes with the catalyst? No, rate constant changes with the catalyst. Okay, this one is first order. Okay, and then for catalyst, how do we know? How do we know that catalyst will change the rate constant? We use the Arrhenius expression. K is equals to A epsilon negative EA over RT lah. Okay. When you use the Arrhenius equation, A is equals to A epsilon negative EA over RT. So there's only one way to lower the activation energy, which is by adding catalyst. Okay. Okay. So when the catalyst is added, it will lower the activation energy. And when the activation energy become low, the rate constant in here will increase. Okay, so yes, it will affect the rate constant. C, it does not. It does remain constant at the constant temperature. So if the T in here does not changes, okay. If the T in here does not change, okay, then your rate constant in here also no change. Okay, so that is for C. And then the decrease as the concentration increases, but concentration will not change the rate constant. Actually, it's only the temperature. Okay, so the best answer in here is C. Okay. What new insight? Okay. So that is for number 10. Okay, so shall we continue to the next one? Okay, number 11. The kinetic data for the reaction A plus 2B gives C at a certain temperature is shown below. What is the rate of the reactions in here? Now, this is actually pretty straightforward. You use the experimental methods to calculate this, where you first write the bulk rate equation. Now, if it is a structure essay, always write like this. First, write the bulk rate equation. Rate is equals to K A power of M B power of N. Okay, you must write like this first. And then step 2 is substitute all the experiment 1, experiment 1, experiment 2, and experiment 3 into the rate equations in here. Okay, so once you substitute all of them inside the rate equation, only then you say you compare experiment 2 to experiment 1. Okay, you cancel B, you cancel K, you cancel K. So you cancel A, you cancel A and A. Okay, so 4 is equals to 2M. So M is equals to second order lah. Okay. And then if you compare experiment 3 to experiment 1, so K and AM both cancel each other. So R and R cancel each other, you get equals to 1, isn't it? So B power of 1 is N, so N is 0 order lah. Okay, so because of this, the rate equation in here is A, K A squared. So this is pretty straightforward, but when it comes to structure and SA, I will really recommend you all to use this technique to solve it, okay? Okay, so that is how you are going to solve for number 11 here, okay? Okay, any questions so far? Which part that you can understand, would like me to repeat for you? Okay, hopefully no problem, huh? Okay. If you ask me where am I, this is my room, so that I can get my pillow. Okay, so let's continue. Okay, then let's go to number 12, shall we? Okay, number 12. The decomposition of the ammonia to its element on the metal surface of a particular temperature is a zero-order process. Which graph shows the correct composition of ammonia? Now, this one is a little bit tricky where as a student, you have to remember some of the basic equation for the order of reaction. Like for zero order, you must know that the zero order equation in here is AT is equals to negative KT plus A naught, typing error in here. A naught. Okay, A naught. Okay, so this is for zero order. And then for first order, first order is ln AT. So this one you have to memorize a bit lah. Okay, ln AT is equals to negative KT ln A naught lah. Okay, so this is for the first order equation expression. Okay, and then for the second order equation, this one is 1 over AT 1 over AT equals to KT plus ln A naught. 1 over A naught, sorry. Okay, so in here, in order to get to your answer, you have to rearrange the equation a bit. So when you rearrange the equation in the zero order, so you get A naught minus AT is equals to KT. So this expression is similar to your Y equals to MX plus C. Okay, so your Y is what? Your Y is A naught over AT against T in here. Okay, so that is why your answer in here is boy B. Okay, can you understand? So that is how you derive from the equation to get this order. But you should know by yourself that the moment that you see is zero order, then this expression should be inside your head already. Just that some of you, maybe you confused with the pattern of the graph instead, all right? Yeah, so I hope that you'll be more careful next time if you see such questions. Okay. Okay, so that is how you're going to solve for question number 12. Okay. Okay, so teacher, do we need to memorize this equation? By right, yes, you have to remember a bit. And then another equation that is frequently come out in STPM is this one, the half-life for the first order. The half-life for the first order, this is only true for first order, please. The half-life of the first order equation, this one is so common that you must be able to remember this. What is the equation? T half is equals to 0.693 over K lah. Okay. So please remember these very, very common half-life equations in here. Okay. Okay, so now because inside my questions, I don't have a discussion for this chapter. So if you have any question in regards to this chapter, you can always ask. Okay, I will try my best to answer. Okay. Ken? Okay, so that is how you are going to answer for question number 12. Shall we move on to the next one? Okay, then we go to number 13. Hydrogen and iodine vapor are mixed at 4 to 5 degrees Celsius. What concentration in mole per decimeter cube of the hydrogen? Sorry, I have a question. A little bit of how do you remember Arrhenius equation when to use Arrhenius equation is to relate between rate constant and temperature, and then Van Hoff equation is equilibrium constant and temperature. So they are brothers, They are brothers, They are brothers. Okay. So later, can you save this question to the later part when after I finish all of this, you can ask more. I'll give you explain in more details. Okay, can I? Okay. Okay. So let's continue on number 13. Okay. Okay. So now in here, you straight away substitute your answer in here. So since H2 plus Hi2 give Hi lah, so your Kc is equals to Hi square over H2 plus I2. Okay. So in here, when you calculate your equation, Hi square over H2 plus I2, you get 0.186 square over 0.03 divided by 0.02, you get 57.7. Now, for this kind of the questions, you have to, of course, you need to calculate one by one, so that you know that your answer is A. But once you get your answer is A, straight away the answer is A already. Okay. So if this is the answer, that's it. Don't go and do BCD anymore. But if you really want to calculate BCD, can you do your own calculation a bit? Sorry, Mr. Chu, too lazy to calculate one by one for you. Okay, so I hope that you understand. Okay, so that is for number 13. But these questions, you have to really calculate one by one. Yes, okay, in order to find your Kc. Okay, so that is for number 13. Okay, shall we continue to number 14? Okay, number 14. An equilibrium system is subjected to the following changes separately. Number 1, decreasing pressure at room constant pressure. And number 2, increasing temperature at constant pressure. The equilibrium systems whose reaction product will increase in the quantity where the subjected about the changes. So if you want to increase the product, in another word, you want your equilibrium to shift to where? You want your equilibrium to shift to the right, isn't it? So if you want to shift to the right, okay, in the sense of the pressure, so you decrease the pressure if you want to cause equilibrium to shift to the right. So decreasing pressure will cause equilibrium to shift to the direction with more total mole of gas. Hence, right side must have more total mole of gas. So in here, A 3 and 2, B 4 and 2, C same, D 0 and 1. So in here, only D has more total mole of gas. So D fulfill the criteria number 1. And then if you want to, increasing temperature will cause equilibrium to shift to the direction doing an endothermic process. Therefore, your forward reaction must be endothermic. So C and D fulfill. Okay. So since D fulfill both of the conditions, so our best answer in here is donkey D. Okay. Now, sometimes be careful. They sometimes use different state of matter. So state of matter, you have, if Kc pressure, it only involves gas only. Okay, so you have to be careful on that. Okay. Okay, so with that, that is how you are going to solve for number 14. Okay. Okay, any questions in here so far? Which part that you feel that you cannot understand and like me to repeat for you? Okay, so if no problem, then we go to the last objective question. So the last objective question sounds like this. An aqueous solution of a monobasic acid has a pH 3.5. 25.00 volume of an aqueous solution of acid is completely neutralized by 27.5. So do we have to write state of matter in the physical? Yes, nowadays they quite stress. Sorry. Okay. Sir, do I need to write the physical state for the equation? Nowadays, yes, they quite stress on the state of matter already nowadays. So yes, you have to this one. Okay. Okay, so go back to the question. So calculate the dissociation constant Ka for the above monobasic acid. So how are you going to calculate that? So first, they give you information of pH. Then they give you the information for the titration so that you can calculate the C. Okay, so let's start with the pH first. So pH is 3.5. So H is anti-log 10 power of negative 3.5. 10 power of negative 3.5. Okay. So then you want to calculate your C. So less concentration of monobasic acid is equals to C. So you use MAVA equals to A over MBVB equals to B. So 25 times C equals to 27.5 times 0.1. So press your calculator. Your C is equals to 0.111, isn't it? Okay. Okay, so when you calculate your C in here, then you have to apply formula already. What are the formula that you have to apply to calculate this one? So concentration H plus is equals to Ka times square root of C. So Ka is equals to, or in here, basically is this one. Sorry, Mr. Chu suddenly jumped to there. So basically, Ka is equals to concentration of the H3O plus square over C lah. Concentration of H3O plus square over C. Okay. So you substitute your concentration of the H3O plus in here into this one, and then your C in here into here. Okay. So you press your calculator, then you should be able to get your Ka is equals to 9.08 times 10 power of negative 3. Okay. Okay, so that is for this one. Okay, any questions? So with that, that is all for the 15 objective question for this paper. Okay. Okay, any questions so far? Which part in here cannot understand and like me to repeat for you in the section A? Okay, so hopefully you all can understand so far. Okay, so without further ado, shall we move to section B? Right, so let's go to section B and section C, shall we? Okay, so for the section B and C in here, okay, time suggests now you already spent 20 minutes for section A, right? So you have remaining 1 hour and 10 minutes. So for the part B, question 16, 17, suggest time allocation is 20 minutes. So answer each question within 10 minutes per question. So that is my advice in here. Wait. This one is previous question. Sorry, I scroll back. Teacher, why H3O plus power of 2? This is a derivation of the equation. For this, you have to go to my YouTube to listen why is it like that. Okay. So, teacher, how many questions do we need to score for section A? If you want to score A, depends on what you want. If you want to score A, usually you have to target around 11 or 12. Okay. Formula is H3O plus K times C. It is a derivation. Actually, you have a few equations in here. This one. Teacher, the ratio is 1:1 because of monobasic. Yes. The ratio is 1:1 because of monobasic. And then you react with the NaOH, correct or not? Okay. Neutralization, titration equation, remember? Okay. Okay. All right. So shall we focus on the section B? Okay, so and then for part C, questions 18 to 20. So you make sure that you read the whole question and answer which questions you are confident the most. So answer each question within 25 minutes per question, and then try to focus only at 2 questions. I'm actually a little worried. Some of you I see only answer 1 essay instead of 2. No, you have to answer 2 essay questions. And don't answer all 3. Please do not answer all 3. If you answer all 3, examiner will only look at the first 2, and then that's it. Okay, they won't look at the third one. No. Okay, so don't answer all 3. Plus, it's a waste of time if you answer all 3. Okay, so that is the strategy lah. Okay, so try not to answer all 3, please. Okay, so shall we move on? Okay, so let's continue with the section B. We have a structure question number 16. A student is provided with a sample of hydrated copper 2 sulfate. Now, these questions is a little bit nagging. Okay, it's very loso one. Okay, so but actually the question can be quite simple. To determine the value of X, okay, you want to study how many hydrated lah. The student dissolve a sample of hydrated copper 2 sulfate water and added to excess potassium iodide to make a total volume of 25.250 centimeter cube of the solution. So according to this equation, so what is this question actually tries to say in here? Okay, so you want to make this to become a volumetric flask, isn't it? So this volumetric flask is 250 ml, 250 ml volumetric flask. Okay, so you add inside here CuSO4, react with the Ki lah. Okay, so now after this reaction take place, now you form a new solution. So now the solution in here let's assume that the reaction is 100%. So now you have I2 and KSO4 lah. Okay, so now you have I2 and K2SO4 and then plus CuI lah. So this I2 that you form in here, you take out of these 250 centimeter cube, you take out how many? You take out 25 centimeter cube, okay, of this product. You go and titrate with the 0.01 of the sodium thiosulfate. You require 20 centimeter cube, okay, of the sodium thiosulfate Na2S2O3 lah. Okay, 0.1. So you see, you are taking 20 centimeter cube to titrate with 25 centimeter cube in here. Do you see the points in here or not? Okay, so that is what this question is trying to ask you lah. Okay, so A, calculate the concentration of the copper 2 sulfate present in the original sample of the hydrated copper 2. That means what is the original concentration of the CuSO4 from here? So how are you going to calculate it? Okay, first you have to calculate the mole of the sodium thiosulfate that you reacted. So you use MV over 1000. Okay, so you use mole is equals to MV over 1000. To calculate, so you have a 0.02 mole of the S2O3. So stoichiometrically, 1 mole of S2O3 is to 1 mole of CuSO4. Hey teacher, why suddenly become like this? How come 1 mole of SO3 is equivalent to 1 mole of CuSO4? Now, if you look carefully, you have to compare in between these two equations. 2 S2O3 is to 1 O2. Do you see that? 1 I2, sorry. And then 1 I2 is to 2 CuSO4. Do you see this? It's like 2 to 1 and then 1 to 2. Do you see that? So can I say it now? Can I say it now straight away? 2 CuSO4 is to 2 S2O3. Okay, so the stoichiometry is 1 to 1 also lah at the same time. You see the relationship in here? So these kind of the questions that involve multi-equations, you have to be compared to your mole very carefully lah. Understand? Okay, so that is why we say in here, 1 mole of S2O3 2 minus is to 1 mole of Cu4. And then don't forget, as we mentioned also just now, we only titrated this 20 centimeter cube with 25 centimeter cube of the sample. So inside 25 centimeter cube of the CuSO4 consists of 0.02 mole. So if you have 250, then you times 10 lah. So you become 0.02 mole in a 250 centimeter cube of the solution. Only then you calculate the concentration. I haven't finished the questions. Sorry. The concentration is equals to sorry, I haven't finished this one. Okay, mark here. Sorry. Okay, so the concentration of the CuSO4 in here is what? But in the answer schema, I already complete the question. Am I right? Okay. CuSO4 is equals to 0.2 times 1000 over 250 lah. So you get 0.08 mole per decimeter cube. Sorry for not completing this solution. Okay. So this is the concentration, which is 0.08. Okay. Okay, so that is for A. And then for B, a total of 7.98 gram of copper sulfate is present in 10.68 gram of the copper sulfate hydrated. 1. Calculate the mole of the copper sulfate in 10.68 of CuSO4. Now, in here, if you student, if you are smart enough, you should know that this is the one that we are calculating, 7.98, not the 10.68. The 10.68 is to confuse you, but if you read to the question carefully, it's the 7.98. Okay, so you calculate the mole of the copper sulfate, you divide equals to 7.98 divided by the RMM of the CuSO4, you get 159.6. So press your calculator, you get 0.05 mole. Okay, and then what is the mole of water inside the 10.68 gram? So since 10.68 gram contains 7.98 gram of the copper sulfate, so how many gram of water? So for the gram of water is you minus so 10.68 minus 7. This one. Okay, so you get 2.7 divided by 18, you get 0.15. So the ratio in here is 3 1 to 3. Okay, so x is equals to 3. Okay. Okay, questions. Teacher, can I use MAVA equals to MVBB? You're referring to A or B? Oh, okay, A. Because why can I use MAVA equals to MVBB or not? Can I use MAVA equals to MVBB? Let's have a look back again at the question. Let's scroll back to the questions. Can I use MAVA equals to MVBB or not? Wait, MAVA equals to MVBB. Your MAVA in here is only for can. You can also use MAVA equals MVBB. Yes, you can. Yes, you can. And the answer is still the same, 0.08. Yes. Okay. Yes, you can. No problem. You can. The answer is still the same, 0.08. Yes, you can. So this is a longer method. This is a longer method. Okay, very good idea. Okay, very good idea. You are correct. Okay. Okay. So can I use I2 concentration for this question? Not necessarily. Not necessarily. Okay, not necessarily. Okay. Any else questions? Okay. So if no problem, then we goes on to the question number 17. Am I right? Okay. So let's have a look at question 17. So a real gas X behave almost like an ideal gas. For n mole of gas X as a pressure P, the graph of the volume against temperature is shown below. A, from the graph, what law does gas X obey? So this is a graph of the this one. Can I compare CuSO4? You don't have to compare CuSO4 and CuI. No need. Actually, it's very straightforward. This question. Okay. Okay. So back to the 17. Okay. So from the gas, what law does gas X obey? Now, because this graph only shows this volume against temperature, so some of you answer ideal gas law. So this is not yet ideal gas law. Because ideal gas law, you have to relate all pressure, temperature, and volume, and also number of mole. But since in here is only volume against temperature, so it's Charles' law. Yes, you're right. Okay. Okay. 2. What is the most probable identity of the gas X in here? So the most probability identity in here is either you write helium or the hydrogen. Only these two gas behave almost like an ideal gas under room temperature. Okay. Okay. So why? Because it is a light gas, which which move very fast. So when you move very fast, you have almost no intermolecular forces in here. Okay. So that is for the number 2. And then number 3, describe the variation in volume with the temperature as lower pressure in here. So in terms of graph, if you have a lower pressure in here, so how would your graph looks like in here? So your graph will looks like this. Okay. So this is under lower pressure lah. Sorry. Can I erase? Sorry. Sorry. We are talking about lower pressure. Okay, so when it is a lower pressure, okay, so your graph should be more or less something like this. So this is for lower pressure. So when you have a lower pressure, that means you have a higher volume. Okay, you have a higher volume. So the volume increase. Okay, so that is a graph for this one. Teacher, can I compare 2CuSO4 and 2Cui? Not necessarily. So for question 16b3, why must use CuSO4 divided by H2O? You just want to find the X, but usually water is greater than CuSO4. Okay. See, can I write the molecular size of hydrogen is small, volume and intermolecular forces can be ignored? You only get 2 marks by stating hydrogen and also intermolecular forces, no intermolecular forces. Okay, and try to do like this. Try to describe like this. You cannot say volume and intermolecular forces of the hydrogen is ignored. No, you cannot say ignore intermolecular forces because you can only say no intermolecular forces between particles, but you cannot say intermolecular forces is ignored. Cannot. Okay, so it's either you say negligible volume and then no intermolecular forces, like that. That is the way of how you should describe lah. Okay, so the way of how you describe your terms must be very you have to be careful lah on how you describe your terms in here. Okay, so that is for number A. Teacher, Oxford book say ignore. Intermolecular forces cannot ignore lah. Volume can ignore lah, but intermolecular forces say ignore. Okay, I don't know lah. I just answer based on what I know. I'm so sorry. Okay, but usually we don't say ignore intermolecular forces lah. Okay, if I'm wrong, then pardon me lah. Okay, so that is for 17A. And then B, at the pressure P and temperature 0 degrees Celsius, gas Y show negative deviation from the ideal gas. Explain the negative deviation in here. So in here, you have to say negative deviation is caused by attraction forces. So what happened when you have attraction forces? When you have attraction forces, the frequency of the collision become lesser than expected. Okay, so PV over RT is lesser than 1. Okay, so that is a key. So teacher, if size is small and weak intermolecular forces, size is small, no. Just like that, just mention that hydrogen and helium is a light gas. Okay, just mention that hydrogen and helium is a light gas. Okay. Okay, so we don't use size is small. We just say that they are light gas. Size is small. I cannot say it's wrong, but that is not the way of how we describe. Okay, usually. Okay. Okay, what else? Good question. Good questions. You at least you have a better idea what is the correct terms that you use in here. Okay. So if no problem, then we goes to question number 18. So question number 18 is an essay. So when it comes to essay, so I will usually recommend students to write more, right? Are you ready? Okay. So number 18, when excited electrons fall from higher level to lower level, the excess energy is emitted in the radiation as a radiation. A. State the energy level transition of an electron that produce Balmer series in an emission spectrum of the hydrogen atom and give the characteristic of the series. 5 marks in here. Okay, if I were a student, I will definitely try my best to describe as fully as I can. Okay, so I will start even from the beginning of the system. So I will mention like this: hydrogen emission spectrum is a single electron system. As electron absorb the energy irradiated to the hydrogen gaseous atom, so the electrons excited to higher energy level. Actually, it's photon energy but just energy is enough already. So electron is excited to the higher energy level. Okay. So, however, excited electron is unstable and tends to fall back to the ground state energy level n equals to 2 in the visible light region. So the first keyword in here is ground state energy level n equals to 2. Second point is visible light region, forming Balmer series. Number 3, spectral line form consists of discrete. Now, because it is a Balmer series, which is from a visible light, try your best to describe as discrete and colorful lines. Okay, discrete and colorful. And the 4 colors is as I shows you in the screen right now. The 4 colors is violet, violet, indigo, blue, and red. This is the first 4 main line. Okay, here. So as the difference of the energy level increases, these lines in the series become closer, hence converge. Okay, so if essay, try your best to describe as fully as you can. Okay, so let's have a look at some of the questions asked by you. So for this question, we need to draw the energy level diagram. You draw also can, but there is no marks. Okay, there is no marks. I never said that you cannot draw. As a student, you try your best to describe as fully as you can, which is very good. Okay. But if you just draw no description, also they won't give you any marks in here. Okay, teacher, when do we need to draw energy level diagram with the question mentioned? Yes, if you look back at all the passive questions that we go through so far, most of them will mention that you have to describe the this energy level diagram. Yes, they will tell you. Okay, teacher, do we need to color the line? No lah. I mean, this is just to show you. Actually, when it comes to describe, you just describe using words. Don't have to color like this. So no need. Don't worry. Okay? No need to color the line lah. No need lah. Okay? No need lah. Because this one, I just helps you to this one. Okay. Can we mention about the wavelength and frequency? I thought the questions have, but No. Question. The question did not ask you to describe about wave and frequency, but if you describe, it is not wrong, but no marks. Okay, and yeah, this one but you can always describe, no problem. Okay. Okay. What else? Can Okay, so no problem. So that will be more or less of how you want, and then like the questions just now, the doing that need the mention is quantized. Can, if possible, also mention. Yes. Okay. The spectral lines form at the quantized energy. Yes, you can also describe. Very good. Okay. Teacher, do we need to end the energy level diagram with infinity? Depends on the situations, but usually so far we haven't really stressed on the you must finish with n equals to infinity. Not necessarily. Okay. So do we need to draw the line spectrum? Because the question is no need. Now, this is a sample of how students should answer. This is just a sample of how students should answer. Okay, so even if you don't draw like this also can. Okay, I'm just answering based on the perspective as a student. Okay, so what I try to tell you in here is you try your best to describe as fully as you can. Okay, so shall we move on to the next one? Okay, so we go for B. Hunt's rule, Pauli exclusion principles, and Aufbau principle are used to determine the ground state electronic configuration. Number one, state the rules and principles. So what are the rules and principles? So you have to mention electrons fill in from the lowest energy level as stated by Aufbau. Then each orbital is occupied by a pair of the electrons. With opposite spin as in Pauli exclusion principle, and then in the Hunt's rule, in a set of degenerate orbitals or orbitals with the same energy levels, each orbital is occupied first by single electron with parallel spin before pairing. So that is the three rules and principle, right? So each of them 1 mark. Number two, describe how the rules and principle are applied to the nitride ion N3- as an example. So definitely the first mark will go to how to write the electronic configuration of the nitride. So electronic configuration of the nitride ion is 1s2, 2s2, 2p6. So according to Hunt's rule, electron is filling from 1s to 2s to 2p. So you use the energy levels to describe about Hunt's rule. Okay. Okay. Then after that, you have to mention where all orbitals this one is a very important keyword. All orbitals in 1s, 2s, 2p are filled with electron with opposite spin as in the Aufbau principle. Okay. Okay. And then finally, as for Hunt's rule, you must specifically mention that it only applies to 2p orbital. Okay. So Hunt's rule is applied in 2p orbital, where 3 orbitals in the 2px, 2py, 2pz is first filled with a positive spin electron before the negative spin is filled. Okay. So like I said, as a student, you try your best to describe. Okay. Questions. Sir, can we write in essay point? You see, when I teaches you all, when I share this section, technique answering session, you see I try to avoid using point form, isn't it? So I do not really recommend using point form. Okay. Try to write in essay lah, jangan tulis point lah. Okay, try lah. Okay. Okay. Okay, number 3, draw the diagram of valence orbital. Valence orbital. So what is a valence orbital in N3-? So the valence orbital of N3- is 2s and 2p. So you should try your best to describe the 2s and 2p and label. I forget to label, but you must label. Okay. So this is your 2s and this is your 2py. Okay, this is your 2pz. Okay, and then this is your 2px. Must label. Okay. Okay, so that is for how you are going to draw a label diagram. Actually, should be label diagram. Okay, it's paragraph. Okay, no problem. So it's 1s, 2s, 2p, isn't it? Aufbau principle. Yes, Aufbau principle. Why? Sorry, typing error. Thank you very much. Sorry, Mr. Chu blur already. Sorry. That's why I say sometimes Mr. Chu also can make mistake. Aufbau principle. Sorry. This is Aufbau. Thank you very much for helping Mr. Chu to correct. Sometimes Mr. Chu also type blur already. Thank you very much. Okay. So that is for the this one. Sorry for that. Okay. So with that, that is the how you are going to answer for essay question number 18. Any questions so far for number 18? For chapter 2 lebih kurang macam itu sajalah. And then you chapter 2 also you must try your best to remember some of the basic equation. At least try to remember Planck equation E is equals to HF. E is equals to HF, quite common. And then Rydberg, not really necessary, but ionization energy is a must. Ionization energy is once you get the energy, you multiply by the Avogadro constant. All the constant value will be given to you in the examination, so don't worry. Okay. Okay, so with that, that is all that you need to know for chapter 2. Actually, chapter 2 is quite easy. Huh? Okay, I see a lot of students, if they see chapter 2, definitely they answer. Okay, all right, so shall we move on to the next one? Okay, number 19. Now, this 19 essay question is some questions that I feel that never asked before, but it has always been in the syllabus. Okay, wait. Teacher, not to be patriotic, but teacher said Aufbau is actually a word of Aufbau's principle. Aufbau's principle with penalized. Actually wrong. But the question already mentioned this one, isn't it? Use the words inside the question. Use the words inside the question. Okay, use the words inside the question. Isn't the question already said Aufbau's principle? Use the words inside the question. Okay. Okay. Can we draw P orbital in the same axis? Yes, you can. You can combine. You can combine. No problem. You can combine. Okay, that's all. Okay. So without further ado, let's go to question number 19. In an organic reaction between Grignard reagent CH3 MgBr with carbon dioxide CO2 forms ethanoic acid according to the equation. Actually, equation is not the main point. And I'm so sorry, I accidentally typed extra CH2. So this one is wrong. Can you help me to correct that? Okay. So, according to the equation, where at first Grignard reagent react with carbon dioxide to form CH3CO minus MgBr plus, and then CH3CO minus MgBr plus H2O plus gives CH3COH plus MgBrOH. This is organic reaction where you are going to learn in semester 3. But because in here, my main problem is not about this organic reaction, is this one. Okay. Okay. Must the energy convert to kJ? Not necessarily. Not necessarily. Okay, you can leave your answer as times 10 power of something joule. Okay, so back to the question. A. Compare and explain the polarity between CH3, MgBr, and CO2. So how are you going to mention this? Of course, you are going to describe that CH3, MgBr is a polar molecule, while CO2 is a non-polar molecule. So that is how you are going to describe first. Okay. So now, how do you explain them? Okay, so first of all, you must use electronegativity factor. So in CH3 MgBr, since electronegativity increase from Mg to C to Br, therefore bond polarity, you have to mention bond polarity in CMg is lower than that of the BrMg. Okay, therefore electron density is directed to the bromine atom, or use diagram to describe it. What do I mean by use diagram to describe is that if you have a CH3 MgBr, okay, like this. Okay, so MgBr. Okay, so the bond polarity is going to this direction, but yet this one is like this. Okay, however, because bromine is the most electronegative elements in here, so the whole key in here, the whole vector will direct towards this one. So hence you have to mention that dipole moment presence in CH3 MgBr. So the overall goes to the Br here. Okay. Okay, whereas in CO2, oxygen is more electronegative than C, therefore bond dipole presence in C double bond O. However, because C double bond O is symmetrical, hence bond dipole cancel off each other, causing no dipole moment presence in CO2. So that is how you are going to describe in details about use electronegativity to describe bond polarity. Use bond polarity to describe whether this molecule is symmetrical or non-symmetrical. Hence, deduce this is a polar or non-polar molecule. Okay. Okay. Questions. So, if final answer must be depends on the questions. Okay, depends on the question. Teacher, for comparison, is it answer better used in table 4 or just write sentences? Both can, but nowadays I don't really think that I don't know lah, but I don't really recommend table form. Though table form can be quite easy for you lah. Okay. Will the examiner deduct mark if spelling some of the chemical terms? If it is a very important chemical terms, then they will penalize. Yes, but they don't deduct mark. They just don't give marks. There is no terms of deduct mark. Don't worry. Yeah? You just don't get the marks. That's all. Okay. Okay. So that is how you are going to describe for this one. Okay. Okay, so any questions? So again, I would like to stress, you have to describe electronegativity, then you have to mention about bond polarity, then if it is symmetrical, they will cancel off each other. But in this case, CMGBr does not cancel off each other because bromine is the most electronegative element. And then if it is symmetrical like CO2, then they will cancel off each other, therefore non-polar. Okay, so that is how you are going to describe about the bond polarity in here, right? Okay, so that is for number 19. So shall we go on to the next one? Okay. B, ethanoic acid has a higher boiling point than Grignard reagent. Explain why boiling point of ethanoic acid, actually ethanoic acid, typing error, so sorry, should be ethanoic acid, typing error, so sorry. Ethanoic acid is higher than that of the Grignard reagent. So you have to mention that ethanoic acid form dimer using hydrogen bonds, which greatly increase the molecular size of the ethanoic acid. So this will increase the strength of the weak intermolecular forces, hence increase the boiling point. Whenever you are trying to describe about boiling point of ethanoic acid, always use these keywords to describe. Number one, form dimer using hydrogen bond. What will it result? It will result great molecular size to increase greatly. So this will increase the strength of the intermolecular forces, hence increase the boiling point. Okay, and then last but not least, you have to mention Grignard reagent is a simple covalent molecule held by weak permanent dipole forces between the molecule. Now you have to understand that because Grignard reagent is a polar molecule, so they form a permanent dipole. So teacher, is it okay that I write weak van der Waals forces? Yes, you can, no problem. Because permanent dipole is part of the weak van der Waals forces. Okay. Okay, so that is for C, B, and then C. Draw an orbital over the diagram. How to draw? Draw like that. Hey, this one you must know, please. This is quite common. You must know how to draw this diamond. Okay. Then C, by drawing orbital overlapping diagram, describe the hybridization occur in both carbon atom in the ethanoic acid. So of course, it's referring to this carbon and this carbon. Okay, so you have to explain from the ground state, excited state. So so this is the ground state. Okay, this is the ground state. This is the excited state. Okay, as for the hybridized state, C in the COH, C in the COH is sp2, whereas C in the CH3 is sp3 okay. So this is the difference between the C2 and C3 in here. Okay, and then you have unhybrid PZ orbitals. So that is used to form the double bond. So if possible, label all the sigma and the pi bonds in here. So that is how you should try your best to describe about the overlapping diagram inside the this one. And I think I labeled wrongly. Correct, no problem. Okay, so that is how you are going to describe about the overlapping inside the ethanoic acid. Okay. So, and then you have to mention C in the CH3 is tetrahedral, C in the COH is trigonal planar. Okay, question. Teacher, is there a way to know whether a molecule is dimer or just remember the important one? There's in our syllabus context, there is only 3 dimer, Al2Cl6 and Be2Cl4. That Al2Cl6 in Be2Cl4 is using the dative bond. And then for dimer is this ethanoic acid using hydrogen bond. That's all. Nada lagi. Okay. Okay, can? Yeah, so that is how you are going to describe about this this one. Pretty straightforward questions. Okay. Okay, any else questions? Can I? Okay. So with that, that is a little bit that all the questions that I asked in here so far, STPM never really stressed. So I just looking for possibilities of what might come out. Okay. Okay, then we goes to the final essay question, which is number 20. For this year, I will stress a little bit on phase equilibria. There is a reason behind this. It's because this your semester is the final semester of this current system. Next year, they are going to launch a new syllabus already. And in the new syllabus, they don't have phase equilibria anymore. So I worry that they want to take out all the question banks that they have. So they might stress on the phase equilibria. Furthermore, if we look back in details on the analysis, 2016 asked phase equilibria, 2020 asked phase equilibria, but 2024 didn't ask. So will they ask in 2025? I don't know. But I just have a feeling that they will ask this year because this is the last year that they will ask about this. Okay. So question number 20 sounds like this. Ethanol is well known as a universal solvent and it is miscible with organic solvent and with water. Okay. So A, ethanol C2H5OH form an ideal solution when mixed with propanol C3H7OH. Given vapor pressure of ethanol and propanol are 77.2 and 46.8 kilojoule kilopascal respectively, calculate the vapor composition of propan-10 when 25 centimeter cube of 25 gram of the liquid ethanol is mixed with 30 gram of liquid propanol. So in here, you have to use the 3 steps inside the Rock's law. Okay. Okay, teacher, what is actually ideal solutions? An ideal solution is when 2 solutions are mixed. Intermolecular forces in ethanol is the same with intermolecular forces with propanol, is the same with intermolecular forces between ethanol and propanol. And then because of these similarities, so there are no heat change, delta H is equal to 0, and the volume, when you add 50 plus 50, it gives exactly 100. Okay, so there is a 3-step methods of how you are going to calculate this Rock's law. So what are the 3-step methods we use in here? Step 1, you've calculated the mole of ethanol and propanol first. So mole of ethanol is 25.0 divided by 46.0, you get 0.5435. And then for mole of propanol is 30.0 divided by 60.0, you get 0.5. Then you sum up the total mole. So the total mole is 1.0435. Then you use the Rock's law. Rock's law in here is the Px PA is equals to XA over P total PA not multiply by the PA not. This is the Rock's law. Okay, so this is for PA. And then PB also you have XB times PB not . Okay. So this one is separated. You have to calculate separately. Okay. So this is the formula for the Rock's law. Okay. So you calculate . So for P ethanol 0.5435 divided by the total mole over the pure vapor pressure of the ethanol. And then for propanol 0.5 times pure vapor pressure total mole, and then times pure vapor pressure 46.8, you get 22.4. So press your calculator, you get 62.6 Pascal. And then only then your step 3 is to calculate the vapor pressure. So 22.4 divided by 62.6, you get 0.358 in 3 significant figure, because all the value in here are 3 significant figure. So your final answer should also be in 3 significant figure also. Okay. So that is the step-by-step of how you are going to calculate using Rock's law in here. Not many students will like this kind of the calculations, but actually it's not difficult. So try your best to learn this as you can. Okay. Does it need to be percentage? No. In composition is usually mole fraction. Composition is usually mole fraction, not percentage. Okay, so in the composition is usually in mole fraction, not in percentage, unless they say state the percentage of composition. So 0.358 times 100%, you get 35.8. Okay, but in this case, just leave it as the mole fraction, no problem. Can? Okay, so that is for how you are going to describe for A. Okay, let's continue for B. When 50 milliliter of ethanol is mixed with 3 liter of water, the volume of the mixture become 100.8. This one. Teacher, what is XA? XA is mole fraction of A. Mole of A divided by total mole. Okay. Is there no unit? Mole fraction don't have unit. Mole fraction don't have unit. Okay. Okay, back to the questions. Okay, so in here you can see when you add 50 to 50, the volume become 100.8. So what does it mean? That means the volume is greater than expected. So when the volume is greater than expected, so this is trying to tell you that this is a positive deviation. When the total volume is greater than expected, then it is a positive deviation. It is a very indirect way to tell you that it is a positive deviation. So given that ethanol boils at 78 degrees Celsius and an azeotropic mixture containing 95.0% of ethanol by mass boils at 77.2 degrees Celsius at 101 kilopascal. So now they only give you boiling point of pure ethanol, which is 78, and they give you azeotropic mixture, which is 77.2. But do you see that there is one more, which is water? Usually they purposely don't give you water, because you have to know that for water it is 100 degrees Celsius boiling point of the water. Okay, you have to know by yourself, right? Okay, 1. State the type of deviation and explain the type of deviation shows by mixture of ethanol and propanol. So mixture of ethanol, propanol show positive deviation. Positive deviation. Teacher, how do we know it's positive? Because the volume is greater than expected. Okay. So why is it that the volume is greater than expected? Because the vapor pressure is greater than expected in Raoult's law. Okay, so why? This is due to hydrogen bond after mixing ethanol water is weaker than the hydrogen bond in between pure ethanol and pure water. Okay, so in other words, intermolecular forces become weaker when you mix both of them together in here. Okay. Okay, so B, sketch a label boiling point composition graph of the ethanol and the water mixture. So you sketch boiling point, then please try your best to remember. Okay, so now your y-axis is boiling point degrees Celsius. Your x-axis is percentage composition of the by mass of ethanol. Okay, so in another word, if this is your 100% of ethanol, so this is the 78%. This is the 78 degrees Celsius. So this is the boiling point for the pure ethanol. Okay, this is the boiling point for pure ethanol. And then for water, this is the 100 degrees Celsius. Okay, so this is the boiling point of water. Okay, so you sketch and then don't forget to label. This is vapor, everything above the curve is vapor, everything below the curve is gas, and the azeotropic mixture boils at 77.2 and 95% of composition by mass of the ethanols in here. Okay. Okay, I see some question. So teacher, if I unsure the resulting bond produced between the miscible liquid, can I just write intermoleculars? Yes, you can. You can try but sometimes they can be quite specific on that. So try your best to remember some of the basic intermolecular forces in between them. Okay. Sometimes they accept. I'm not going to say guarantee they won't. Sometimes they do accept. Okay. All right. So that is the how you are going to give the graph in here. And then finally, state the changes which occur in the composition of the residual mixture and the distillate when the solution containing 40% by mass of ethanol is continuously distilled. 3 marks in here. Okay. So now, in other words, if this is your this one, so you're going to start from 40% of the ethanols in here. So this is your 40% of the ethanol. Okay, so what happened if we brought to the fractional distillation? So in the fractional distillation, vaporize, condense, vaporize, condense, vaporize, condense, vaporize, condense, vaporize, condense. So at the end, what will be your distillate? Your distillate will be the azeotropic, as the temperature decrease, you see, as the temperature decrease, concentration of ethanol increases. So you see the ethanol become more and more. Do you see that? Concentration of ethanol increases because going to here is the increasing of the percentage of the ethanol. So you have to mention as temperature decrease, the concentration of the ethanol increase inside the distillation. So azeotropic mixture will be first distillate out while water will be the residue in here. Okay. So your distillate will be azeotropic mixture, but your residue is water in here. Okay. So you have to be very good in describing the positive and negative deviations in here. Okay. So for more details, you can always go to my YouTube and have a look in other videos that describe in details of all these intermolecular forces. All right. Okay, so with that, that is the discussion for the papers that I prepare for you. So let's go to the Q&A session, shall we? Okay. So if you have any questions that you want to ask, I have about 20 minutes for you to ask. So feel free to throw in any questions, and if I can, then I will this one. Okay. Okay. Stop screen. Present. Share screen. Wait, wait. Screen to share. Okay. So teacher, Van Hoff and Arrhenius equation. Okay, can no problem. Wait. Okay, discard first. Wait, can I discard this for time being? Okay, so Van Hoff and Arrhenius equation. So can you give me one moment? Okay. Sorry, take your little time. I'm going to show you Van Hoff and this one. Give me one moment. Sorry. Okay. Okay, so let's start from the Van Hoff equation first, shall we? Okay. So in the Van Hoff equation, so this is the equation for the Van Hoff equations. Okay, so showing to you in here is the Van Hoff equation where you have this derivation where you have ln k equals to negative EA over RT in here. So if you plot the graph of ln k against 1 over t, you get a negative gradient graph. So here are the steps. Okay, so first of all, you need to calculate the 1 over t and rate constant. You have to calculate, and then you plot the graph. You plot the graph. Okay, so this is the graph that you plot. And then you find the gradient. So the gradient in here is actually equals to EA over R. The gradient is actually EA over R. Okay. So that is why you this one, okay, you need to calculate like this. Okay, now this is a Van Hoff equation. Okay, then the next one is the Arrhenius equation. So Van Hoff equation, sorry, Van Hoff equation. Okay, Van Hoff equation, you have two possibility, you know. Can you give me, okay. So this is a Van Hoff equation, okay. So in the Van Hoff equations, this is the equation where you have ln k is equals to negative h over RT. Now, isn't it looks a little bit similar to that of the Arrhenius? Yes. So what am I trying to highlight in here is Arrhenius is used to find activation energy. Van Hoff is find delta H. So in delta H, you can have positive, negative. So this is the expected graph. This is the expected graph when you have the endothermic and exothermic process. So if you plot a ln k against 1 over t, okay, when you plot the graph of ln k against 1 over t is for is positive gradient, then it is exothermic because your positive gradient is equals to negative delta H over R. Okay, then you get your process is exothermic lah. If it is an endothermic process, your ln k against 1 over t is endothermic. Okay. Okay, so that is what I can describe about the Van Hoff. So if you want more, you can go and have a look at the examples. I also have examples inside my this one. You can go through by yourself in the YouTube later lah. Okay. Okay. So that is for my current explanation. Okay. I hope that it satisfied your this one. Curiosity. Okay. Okay, next question. Teacher, I'm not very good at sketching. Can you explain in words? Yes, you can explain in words. Actually, in that situations, in just now the 6B3, 6B3, you don't have to draw out from the graph also can. You can just describe using words. Actually, all the marks are inside the words. As the temperature decrease, concentration of the ethanol increase. So as a result, the ethanol is the distillate while the azeotropic mixture is the distillate while water is the residue. Actually, that kind of question only require you to describe using words. Yes. Teacher, can you explain briefly about the dimer formed through the dative bond and hydrogen bond? Okay, sure, can. No problem. Give me one moment. Okay. So, okay, what am I about to show you in here is the this one. Okay, so this is the wait. Okay, so what am I about to show you in here is this one. Okay, the formation of the dimer in here. So in the formation of the dimer in here, as you can see, we uses okay, so as you can see in here, we uses this dimer of Al2Cl6 in here. Okay. And also the dimer in the B2Cl4 in here. So both of them uses the dative bond in here as you can see. Okay, and I also have some other application of the dative bond that you might want to know. Among the most common application is the water and the hydrogen ion to form the hydroxonium ion, ammonia with the hydrogen ion to form hydrogen ammonium ion. This one, ammonia react with boron trifluoride. This is also dative bond applications also. Okay, so try your best to remember this one. Okay, so this is the dimer inside the this one. Okay, as for the dimer using the hydrogen bond, okay, this is what we are talking about, this one. Okay, so this is where I mentioned about the ethanoic acid, we have a higher boiling point because you form dimer using strong hydrogen bond. Okay, so that is what we are looking at. So this one you have to, no choice but to memorize a little bit. Okay. Okay, so I hope that I answered to your questions. Okay, teacher, about the Van Hoff equation, when the forward reaction is endothermic, how does the constant changes with increasing temperature? This one, if you look back at the, sorry, now if you look back at our slide just now, I've already mentioned that. What do I mention just now? Oh, okay. If you look back at our this one just now, I've already mentioned that increasing temperature will cause equilibrium to shift the direction during an endothermic process, hence to the forward reactions. So basically, this is what we are trying to ask students to this one. So if always remember, temperature is the only factors that will change the equilibrium constant, Kc, Kp in here, okay? So therefore, you need to describe if the forward reaction is endothermic, okay? So equilibrium shift to the right. So therefore, product increase. Always remember, in temperature, when we say equilibrium shift to the right, product increase, reactant decrease. Therefore, K value will also increase. Okay. Okay. I hope that is clear. So, teacher, how do you find activation energy in any question? Activation energy is only through this Van Hoff equation that I introduced just now. Okay. Only through the Van Hoff equation that I introduced to you just now. Okay, so that is the only way that you can find the Van Hoff equations. Okay. So the final answer for every calculation, does it fix or how many decimal place or significant figure? Okay, it depends on the question. If let's say a question has 3 significant figure, 2 significant figure, usually we go for 2 significant figures. But sometimes it can be quite complicated. So I sometimes find difficulties on answering to you this. Okay, generally look at the question. If question is using 2 significant figure, answer is 2 significant figure. If question using 3 significant figure, then answer is 3 significant figure. Okay. I believe that they will try their best to this one. So teacher, how do we remember a miscible solution is positive, negative from the Rod's law? You can go to my YouTube. My YouTube there explain quite details. Okay, how to know whether it is a positive, negative deviation. Because this one also take quite lesson. So I advise you to go to my YouTube later. I got phase equilibrium via YouTube. Okay. Teacher, is there any unit that has a fixed decimal place? No. There is no such thing as fixed decimal place. No. Teacher, do we need to draw dative point in our Lewis structure? Yes. You have in certain case you have to draw the dative point. In here, class, I'm going to show you this one. Wait, okay. In our STPM context, you only have 4 structure that you need to remember, about the formal charge, and this one, which is this one. Okay. So sorry, I scroll back. Okay, there's only this one is the one that you need to know where is the formal charge in here. So the most important part in here is Cn minus our CD first, our objective. You must minimum know how to draw these 4 molecular ion in here. CO3 2 minus, Cn minus, this SO4 2 minus, and also NO3 minus in here. Okay, only these 4 okay. Okay. Hope that is solved. Teacher, for comparison question in essay, can we use a table to this one? If VSEPL theory, yes. VSEPL theory, yes. You can use a table, no problem. Okay. Okay, teacher, can you demonstrate how to draw the orbital overlapping question in 19C? Can I demonstrate? Okay, I have a little time, so because I don't see any other question else, so I can, yes, I can, no problem. Okay, same slide in here. Okay, okay, I'm going to show you about some of the basic theories and principle of this. Okay, so this is the most basic CH4. And then this is the most basic BCl2. Okay, so this is how CH4, BF3, BeCl2 looks like. Okay, okay. And then for multiple bond, okay, so this is how you are going to draw for ethane molecule. Okay, and then this is the ethene. Now inside a single bond, okay, so this is sp3, where this is, you have this one, and then this is sp2. If you want to show double bond, you have to describe at least the one of them is unhybrid orbitals with one single electron, like I show you in here. If you want to show triple bond, then you must have two unhybrid orbitals where each of the orbitals contain one single electron in each orbitals. Okay, so that is how you are going to describe in here. Okay, and then yeah, and then in this case, it will straight away influence the bond length. So the bond length becomes shorter. Okay. Okay, so for the example of the molecule just now, okay, so this is hydrogen cyanide. So hydrogen cyanide, later you can screenshot by yourself. You can look back at this one. So, wait, sorry. Sorry, I hide this. Okay, okay. So this is the, if you cannot see the CN part, I'm so sorry because of this one blocking. Because if I close like this, okay, okay. So now, in this case, this is how you are going to draw the HCN, HCN, and this is how you are going to draw the amide in here. Okay. So this is what I can at least shows to you lah. If I want to demonstrate, it takes some time to draw, and I don't think I have the time to do that lah. Okay. This is some other else examples. Okay, so this is the unhybrid, and then this one. Okay, okay. So sorry lah, because of the time constraint, I cannot show you everything. Okay, where are we just now? Okay. Teacher, how do you know which one is distillate, which one is residue? Look back at the YouTube. I explained about that in the phase diagram. I have other YouTube for that. You can look into that. So, teacher, your phase, do you mean the positive negative is in the mixture? It depends on the description. Like in that case, just now 20B, the question already tries to tell you that it is a positive deviation because volume is greater than expected. Volume is greater than expected. Okay. Okay. And then, teacher, what is the most frequent chapter? I don't know. Don't ask me to predict. Okay. Teacher, will this string available after that? Yes, it will be available after this one. No problem. Okay. So, teacher, pH and AR should follow DP. pH means what? Yeah. Like I said, it depends on the question. It depends on the questions. Okay, so yeah, so I will get to what we need to know in here. Okay, okay. Okay, so I guess that is all for our talks for today. So good luck to all of you in your coming SEM 1 STPM, which is this coming Wednesday. Okay lah. Okay, and finally from me, before I end my last session for today, always remember that you are who you believe in yourself. Okay, so for me, Mr. Chu, I never believed that I can do all these. If you look back at the old video YouTube, I was very fat. But today I'm already a 3-time Ironman finisher. So if Mr. Chu can do it, you all also can do it. Okay. So all the best in your SEM 1, and I'll see you all in SEM 2 and SEM 3 in the future. So for every SEM, I will do this kind of answering technique. Okay. Okay, so with that, I end my session for today, and all the best and good luck in your coming examination. Right? Okay, thank you very much, everyone. Have a nice rest. Thank you.